at how we can find the vertical and horizontal intercepts using here technology. For the vertical intercept, we can find that quickly just by evaluating our function for an input value of 0. So here h of 0 equals 2 times 0 cubed minus 5 times 0 squared plus 4 times 0 minus 1. So our first term goes to 0, our second term goes to 0, our third term goes to 0. We're left just with minus 1. So our vertical intercept as a point is 0, negative 1. For the horizontal intercept, this is where the technology comes into play. So the other strategies we've seen have been, if it's already in factored form, we can set each factor equal to 0. If it's not in factored form, we can try to factor using grouping or strategies for quadratics. But here, we're not able to factor our given function. So this is why we need technology on this one. So for us, technology means either using Desmos to find our horizontal intercepts or our graphing calculator. Let's look at both of those options. So first, looking at Desmos, we first want to type in our function here on the left-hand side. So we have 2x to the third minus 5x to the second plus 4x minus 1. So we can zoom in on our function here, and notice that on Desmos, when you click on the function, it then marks key points on our graph. So 0, negative 1 is the vertical intercept that we just found algebraically, and then we can also click on our two horizontal intercepts, and Desmos will label them for us. So we have the points 1/2, 0 or 0.5, and then also 1, 0. And notice the different behavior at each of these, that the graph is crossing through at 0.5, 0, but it's just touching at the point 1, 0. So now if we come to our graphing calculator, to be able to do this same strategy on our graphing calculator, we head to our y equals menu, and for our y1, we'll put in our function. So 2x to the third minus 5x squared plus 4x minus 1. If we just hit graph, it'll graph in our standard viewing window, which uses an x min and max of negative 10 to 10, and then same for the y values. So it's pretty challenging to see where our intercepts are and how many we have. So we could zoom in on our graph here and look, say, just from 0 to 2 on our x-axis, changing our x min and max, and we could go from negative 2 to 2 on our y's. So let's hit graph now. And it's a little bit easier to see those same points that we saw on Desmos. Still not quite as clear as just the zoom feature on Desmos. On the calculator, the way that we can find these intercepts is to use the calculate menu by hitting second and then trace. So another name for our horizontal intercept are the zeros of the function. So we're going to use option 2. So this puts a cursor on our graph. And we want to move our cursor over to the left of that first intercept that we were interested in. So I'm going to hit enter to tell my calculator to start looking here, and then move over to the right and hit enter. When we hit enter again, it'll move the cursor to that point. So there's the 0.5, 0 that we found before. And then we just repeat that process again, hit second and trace, pick our option 2 for 0. So we can move over a little closer, hit enter for the left bound, move over to the other side of our intercept, hit enter, and then enter for the guess. You can see the graphing calculator does a little bit of approximating, so 0.9 repeating, we can think of that as the same point 1, 0. So if you're working on your graphing calculator, second and then trace opens up the calculate menu where we can find zeros of the function. If you're working inside of Desmos, then we can graph our function, zoom in, and just click on the graph. Clicking those key points will give us the labels for each of those points.